Hello, bachcho. Let's read the question. The question says that a perfectly reflecting mirror of mass m mounted on a spring constitutes a spring mass system of angular frequency omega such that 4 pi m omega by h is equal to 10 to power 24 per meter square with h as Planck's constant, n photons of wavelength lambda is equal to 8 pi into 10 to power minus 6 meter strike the mirror simultaneously at normal incidence such that the mirror gets displaced by 1 micrometer. If the value of n is x into 10 to power 12, then the value of x is, consider the spring as massless. So we will solve this question. First of all, we will see what will be the key concept used to solve this question. The key concept that will be used to solve this question will be conservation of linear momentum. Conservation of linear momentum. Now we will assume let momentum of one photon, let momentum of one photon be p, and after reflection let velocity of mirror, after reflection let velocity of mirror be v. So we will applying conservation of linear momentum and conservation of linear momentum. We will have, as there are n photons incident, so n into p into I cap, because the photons are incident at 90 degree to the mirror at normal incidence to the mirror. So if we take the direction of mirror is on y-axis, this is y-axis, so photons are incident on the x-axis. That's why np I cap is the initial momentum and it is perfectly reflecting mirror. So all the photons will be reflected and it will be in the opposite direction. So final momentum will be minus np I cap plus the mirror will have some momentum due to the velocity, that will be mv I cap, where m is the mass of the mirror. Now from here we will have mv I cap is equal to 2np I cap, or we will have mv is equal to 2np. Now since v is the velocity of mirror at mean position, so v will be equal to a omega, where a is the maximum deflection of mirror from mean position, maximum displacement of mirror from mean position, which is given as 1 micrometer. So this will be 10 to power minus 6 omega. This will be v, and omega is the angular frequency of spring mirror system. So now we will calculate momentum of one photon. P will be equal to h by lambda. Therefore mv, which is equal to 2np, that will be equal to m into v is a omega, that will be equal to 2 into n into h by lambda. So from here we will have n is equal to m omega by h into lambda a by 2. Now we have been given m omega by h, that is equal to 10 to power 24 by 4 pi per meter square. This is m omega by h, that will be equal to 10 to power 4 by 4 pi per meter square. This is capital M. Capital. So we will put this value. So we will have lambda, and lambda is also given as 8 pi into 10 to power minus 6 meter. This is per meter square and this is meter. So we will put the value to calculate the value of n, that will be equal to 10 to power 24 by 4 pi into lambda is 8 pi into 10 to power minus 6 and A is 10 to power minus 6, 1 into 10 to power minus 6 because A is 1 micrometer divided by 2. So from here N will be equal to 10 to power 12, which is equal to x into 10 to power 12. So from here x will be equal to 1. So the value of x is 1. So the final answer is 1. Hope you all understood it well. Best of luck.